Okay, so I pasted the table from problem number 16 into this recording. And so this says to part A says, this is Atlantis. We make two things in Atlantis. So when I want to say, hold on a second, when I say, what do we produce? I'm doing this in Paint, so it's a little bit different. What do we produce? We produce potatoes, and we produce fish. Okay, and then the table gives us how much we produce, and the factors of production here are not exactly relevant. And the opportunity cost we're actually going to end up having to calculate. So let's just start with part A. Part A says, draw a production possibility frontier with potatoes on the horizontal axis, and this is why I did this in Paint, so I could get better lines. So let's see if I can get nice axes. Okay, and then, no. Just straight. Perfect. And then, let's see, can I get you? This thing is a little finicky sometimes. Let's just, all right, beggars can't be choosers. Okay, so this says it wants us to get potatoes on the horizontal axis and fish. So I'm just going to look, it tells us to draw the production possibility frontier, which is exactly just us kind of plotting all these points. So I'm looking at potatoes and the quantity of potatoes, and I'm just going to go, I think, by 200s. So this will be 200. Let's say this is 400, this is 600, this is 800, and this is 1,000. And then I'm looking over at the fish, and I'm going to say I'm going to do the same sort of the same thing. Let's say this is 200, 400, 600, 800, 1,000. It's a little tight, but it'll be fine. So 1,000 on for point A would be right about here. We have 1,000 potatoes and 0 fish, so that's point A. Okay. Then we have 800, 300. So remember, this is 800. So 800, 300 is about, so it's in twos. So 300 would be about here. So this is B. Okay. Then 600, 500. So this is 2, 4, 6, 600, and 500, 2, 4. So that would be about here. So that's C. Then D is 400, 600, so that would be about here. And then we have E, which is 200, 650. So we have 2, 4, 6, 650 is about here. And then 0, 675, so just a bit above that, so that would be here. And this was E, and this was F. So our production possibility frontier would just literally join all of these lines. Let's just pretend that's all nice and connected. Okay, so part B says, can Atlantis produce 500 pounds of fish and 800 pounds of potatoes? Well, let's think about where that would be. So 500 pounds of fish and 800 pounds of potatoes. So 2, 4, 6, 800 pounds of potatoes, 2, 4, 500 pounds of fish would be about here. And if you remember from our classes and our other problems, anything that extends beyond the production possibilities frontier is not feasible. We can't do it. So no, Atlantis cannot produce 500 pounds of fish and 800 pounds of potatoes. If you wanted to explain this, I think an appropriate answer is that this point lies beyond the production possibility frontier. Part C says, what is the opportunity cost of increasing the annual output of potatoes from 600 to 800 pounds? Well, let's go over here. Let's look at potatoes. Remember when we talk about the opportunity cost, we are talking about how much of one thing you have to give up in order to gain something else. So here it's telling us we are gaining from 600 to 800 pounds of potatoes. What it's asking us is how much fish are we losing? So we're gaining from 600 to 800 pounds of potatoes, and it wants to know how much are we losing, right? So to gain that, we've lost 200 fish. And that would be, so B is the opportunity cost is 200 pounds of fish. That is the opportunity cost for 200 pounds of potatoes that we gained. Then part D says, what is the opportunity cost of increasing the annual output from 200 to 400 pounds? Again, okay, what they are really asking us is how much do we lose by gaining 200 pounds of potatoes? So when we go from 200 to 400, how many fish do we lose? We lose 50. So the opportunity cost of gaining 200 fish from 2 to 400 is 50 pounds of fish. E says, can you explain why the answers to parts C and D are not the same? What does this imply about the slope of the production possibility frontier? Well, what you could say, this is part D, is that the production points, the opportunity cost is increasing. Okay, so consider, for instance, let's erase this here and this here. And let's just consider the movements. Okay, this here we're gaining 200. Over here we are losing 50. So the cost, I should have just left that 50 there. So the cost of moving from 2 to 400 is a loss of 50. Consider what it was to go from 0 pounds of potatoes to 200 pounds of potatoes, right? So we still gained 200. But what we lost was actually only just 25. Then again, when we go from 400 to 600 pounds of potatoes, we're still gaining 200, but now we are losing 100 pounds of potatoes. And so on. Right here, again, we're losing 200 pounds of potatoes. And then 300 pounds, all for each time a gain in 200 pounds of potatoes. So what this tells us is that we have increasing opportunity costs. It is costing us more and more and more to get the same increases in potatoes. We're going from a loss of 25 to a loss of 50 to a loss of 100 to a loss of 200 to a loss of 300. It's costing us more in fish each time we bump up by 200 potatoes. So I would say that an appropriate answer there is increasing opportunity costs. What does this say about the slope of the production function? Well, the production function we know has this shape when we have increasing opportunity costs, and let's consider that kind of curve. We've done this in the first few weeks of class, and now let's consider the slopes of that are tangent to tangent to this curve. Well, these are negative lines. And where, so let's say somewhere we have a place where this peaks out and this is 0. Well, we might consider that this might be maybe negative 0.5. This is getting steeper, so we're going to say negative 0.1. This is getting even steeper, so negative 0.2. And so each time we're getting lower. We're decreasing. So this is negative decreasing. So we could say that the slope, what this implies about the slope of this line, or what you could say increasing opportunity costs are associated with a curve that the slope of which is negative decreasing. You could also say something like the slope of the curve is negative and is getting more and more steep as it moves from left to right. And what does that mean? It just means that you're having to lose more and more. Okay, so that is part D, and I hope that makes sense.